Okay, so let's just continue from 20. So structural isomerism and stereoisomerism should be considered when answering this question. How many isomers with the formula C4H8 have the structures that contain a pi bond? तो इसमें वो जो cyclic जो होता था isomer वो नहीं consider करेंगे because pi bond चाहिए मतलब double bond चाहिए आपको. And you can look at structural and stereo. So let's just make them. So I don't think we need to worry about hydrogens. If you like a double bond hai and 4 carbon hai, तो like आपका वैसे ही alkene बन रहा है, so that should be fine. So this is ये आपका एक बन सकता है, and if you really look at this, so this is CH3, and the other thing attached to this carbon would be hydrogen. Same here, a little off diagram, but hopefully either आपका CH3. So basically, because the double bonded carbons are attached to two different groups, that is, one is hydrogen, one is methyl group, same with the other double bonded carbon, they can form cis and trans. So these can form two isomers, where एक में, let's just say, एक is one what I drew above, whether H ऊपर है CH नीचे, and middle में इस तरह से CH नीचे नहीं बनाया, but that could be your cis, and one is where you just flip one of them, so where the same groups aren't on the same side. So either CH3 कर दो. So this should be your trans. So if I call this, let's call this the first isomer, we call this this is cis, we call this the second isomer. So we have two isomers. इसमें optical का scene नहीं होगा, because for that you need a chiral carbon, which I don't think we'll be able to get here because of the double bond. Chiral carbon, just to recap, were those this carbon was attached to 4 different groups. So with a double bond, that's very difficult to do. But definitely you can have structural. So एक में double bond को side में कर दो. You can call this isomer number 3. I think, what do you call it? A position isomer?
Yeah, this is a position isomer.
And another one, I guess, branch को थोड़ा छोटा कर लो. You just attach it like this, and that will be number 4. I don't know what you call this though.
I think carbon chain isomer. It's to do with the length of the longest chain of the carbons. So
yeah, but yeah, you don't need to know the name, and it's a structure.
Well, actually, you need to know them for paper 2.
Yeah, I mean, definitely. I mean, abhi you don't need to know it. But chain isomer, something of that sort. So you have two stereo isomers and two structural, and your answer should be D. Say
yeah.
So let's continue to 21. Kerosene is used as an aircraft fuel. Q is one of the molecules in kerosene and has the skeletal formula shown. Other structural isomers of this molecule are also found in kerosene. Which structure is a structural isomer of Q? So basically, कुछ ना कुछ उन्होंने flip कर दिया, but overall carbons and all same way चाहिए. I'm thinking D वैसे, because what I'm thinking is that they took this and they took this and इसको इधर and इधर attach कर दिया. And बाकी I think it's the same, or isn't length बढ़ रही है? Okay, is it length बढ़ रही है? Either it's 1 2 3 4 5 6 7. Either it's 1 2 3 4 5 6 7. And the length is the same. So I think we can confirm D.
Probably. Yeah, seems like it.
Yeah. बाकी options को देखना है, are we good with this?
देख लेते हैं just in case we don't make a mistake.
But like basic ideas, you just have to count like all the carbons and उस हिसाब से आप बस देख लो. Structural isomer में if you just like if this is 1 2 3 4 5 6 7 8 9 10 carbons overall. If you count here 1 2 3 4 5 6 7 8 9 10, इसमें भी 10 है, तो शायद हाइड्रोजन का मसला हो. 1 2 3 4 5 6 7 8 9, तो B is clearly wrong. 1 2 3 4 5 6 7 8 9 10 11, so C is wrong. So the debate is between D and A, depending on where you have क्या कहते हैं
Number of
hydrogen.
hydrogens. Yeah.
But I don't understand. Did I count this correctly? So there's 1, there's 2, there's 3, 4, 5, 6, 7, 8, 9, 10. मैं समझ नहीं आ रहा उन्होंने किया कैसे होगा इसे बनाया कैसे होगा 2, 3, 4, 5. या तो उन्होंने बेसिकली उन्होंने क्या आई थिंक काम किया इन्होंने साइड से एक कार्बन लिया है and they've attached it like ऐसे and उन्होंने फिर ये कार्बन ये लिया है and they've taken this and attached it ऐसे. Hydrogens को भी count कर लेते हैं, kind of boring thing, but either you'd have 3, you'd have 2, which makes it 5. Here you'd have 1, which makes it 6. Here you'd have 3, which makes it 9. 2, which makes it 11. 3, which makes it 14. 1, which makes it 15. 1, which makes it 16. 19 and 22. And you just count it here. This was 22 hydrogens. This is 3. This is 3. This is 3. Wait, let me just rub the bakwas that I drew. Say it. So yeah, so this is 3. 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 So 1, 2, 3, 4, 5. 15 इधर हो गए. 16, 17, 18. And you have 2 here, so 20, 22. So yeah, in fact, it would not be D, it would be A. Because I'm pretty sure if you count D के फिर hydrogens, तो उसमें I think मसला आ रहेगा.
होना चाहिए.
हाँ. Do you want to count them or do you think it's enough to deduce this?
Yeah, maybe probably A ही होगा फिर.
हाँ. सही है. गिन लेंगे. 22. So which radical is most likely, okay? Most likely to be formed by the homolytic fission of one covalent bound in bromochloromethane. Yeah, idea is the one which does not have chlorine. Sorry?
नहीं, would it not be A because bromine ज़्यादा आसानी से नहीं टूट जाएगा?
My bad. So the one which does not have bromine because bromine की bond length ज़्यादा है, because it's just if you look at the periodic table as you go down group 7, the bond length increases, which means the bond becomes weaker. So that's the bond that's most likely to break, and hence you have क्या था bromine जिसमें नहीं होगा, which is A. So 22A. Propene undergoes a variety of reactions. Which row is correct? When you add Br2 aqueous to propene, you get 1 bromopropane. You should get dono attached. I mean, like if it's a propene, yeah. So you should get Br here and Br here. Or since it's aqueous, then Br in one place and OH in the other place. So yeah, so A, it won't be A because it only one Br is attaching. Cold dilute acidified KMNO4, which is diol formation. नहीं इससे propanoic acid नहीं बनेगा. In fact, all that would happen was this. आपका double bond टूट जाएगा and OH diol formation. Hot concentrator होता तो फिर हम उस पे consider कर सकते थे. Okay, HBr 2 bromopropane. Yeah, this can happen because idea is basically what happens is if क्या कहते हैं ये डबल बॉन्ड था तो ये डबल बॉन्ड टूटता है, इधर आपका Br लगता है, इधर आपका H लगता है, and this is the major product. Although the H can be in the middle, the Br can be outside, but this is definitely the major product because of the Markovnikov's rule.
Yeah.
And अगर आप hot concentrated acidified KMNO4 डालो, so the reason why you won't have propanoic acid is because
ethanoic acid.
Ethanoic and methanoic acid. Sorry.
No, only ethanoic acid.
Only ethanoic acid?
Yeah.
Sorry.
Because the other
and the other one is CO2 and H2. Yeah. My bad. So remember when you're putting a hot concentrated acidified KMNO4, when the double bonded carbon is attached to one more carbon, so it will break to form the acid. तो इधर आपका double bonded O लग जाएगा, इधर आपका OH हो जाएगा, which is basically ethanoic acid because there are only 2 carbons. And the other carbon, because the double bonded carbon is not attached to any other carbons, it will simply form carbon dioxide, gas, and water. And in cases where the double bonded carbon is attached to, not one but 2 more carbons, it forms a ketone. Something
Yeah.
of this sort. कि अगर आपका ये ऐसे कोई scene था, and this was further attached to 2 more carbons, तो इधर hot concentrate डालोगे तो इधर it will just form a ketone. So it's 23C. 24, polymerization of ethene gives polyethene. How does the bonding between carbon atoms in polyethene compare with that in ethene? Longer, stronger, longer, weaker, shorter, stronger, shorter, weaker. Polyethene में क्या सीन होता था?
Polyethene में जो आपके pi bonds हैं वो they get used up and they form only sigma bonds, right? So
Oh yeah. So instead of having this, you'd have long chain of this.
yeah,
So basically, because आपके pi bonds नहीं हैं, so bonding there should be longer
and weaker.
and weaker. So yeah, so 24B.
And a lot of people get confused in this part because pi bonds are generally more reactive and they think that that makes the bond itself, the whole bond, weaker. So if SN you could explain that.
To me, girl.
Acha.
Are you talking about the combination of the pi and the sigma bond? Right? To me, girl, explain, I think.
So because in a double bond we have 2 bonds basically. So there's sigma bond, there's a pi bond. So there's already a sigma bond that already exists in it, and there is an additional pi bond which makes the bond stronger. But in the case where we have a saturated compound, basically the compound becomes saturated once it undergoes polymerization. There are no pi bonds in it, and we only have sigma bonds. That is why it's a weaker bond. But again, pi bonds have greater electron density, which makes it very prone to electrophilic attack and all of that. So that was what I wanted to talk about.
So basically, like, don't look at it like, okay, ये pi bond है, लेकिन pi bond reactive होता है. Look at the entire thing.
Yeah.
कि sigma भी है, sigma तो है ही, additionally pi bond है. So this should be, if this is the case, this should be shorter and stronger. And the pi bond चला जाता है, then you have longer and weaker. So like, look at the bonding between the 2 atoms, not just one particular bond. So 24B, 25, diols in which both hydroxy groups, so hydroxy groups are OH groups, are bonded to the same carbon can spontaneously eliminate a molecule of water to produce a carbonyl compound. Say which compound after complete hydrolysis gives a positive reaction with Tollens reagent. So you need an aldehyde for something to react with Tollens reagent, where basically something like this होता है, and इधर जो भी हो, doesn't matter. So ये so इन्होंने बोलने कह रहे हैं कि अगर हम हाइड्रोलाइज करें इन्हें, positive reaction देगा with Tollens reagent. So I think what they mean to say कि hydrolysis से आप जो bromine लगा हुआ है, you replace that with OH. सही है, and if the two OH are on the same particular carbon, तो वो spontaneously जो खुद से हो जाएगा, they will produce a carbonyl compound which would be aldehyde. सही है?
Looks like A to me.
Well, it can't be B or C because here we're talking about the hydroxy groups bonded to the same carbon, and agar the bromine groups are not bonded to the same carbon, then when you hydrolyze it and you substitute it with OH, तो वो भी same carbon में नहीं होगा. तो या तो
one होना चाहिए क्योंकि बिल्कुल edge पर होगा तभी aldehyde बनाएगा, वरना
exactly. So like if you just take this as an example, हमने इधर पहले Br था, then OH आया, then eventually this spontaneously did इधर उन्होंने carbonyl बना दिया. But the reason why it should be on the edge, which is why 1 is required, ताकि right side and side पे hydrogen लग जाए, ताकि Tollens reagent से aldehyde react हो. वरना बीच में है तो it would have a carbon here and a carbon here, which is a ketone which wouldn't react with tolerance. So 25A. 26, propan 2-ol undergoes many reactions. Which row is correct? Acidified KMNO4 to propan 2-ol. So if you have propan 2-ol here, so yeah,
aldehyde नहीं बन रहा, so the ketone
yeah, so
बनेगा.
this shows an aldehyde because it shows it basically shows ये जो है आपका as C double bond OH. However, if you do add hot concentrated KMNO4 oxidize हो जाए तो this should turn to a ketone. फिर बीच में ना propan 2-ol, so ये तो नहीं है. Propan 2-ol में आप Cl2 डालोगे तो नहीं, Cl2 से I don't think आपका nucleophilic substitution होता है. You have to add some कौन सा proper like Na Cl2 का कुछ NaCl something of that particular sort, something that makes it more reactive, right?
Yeah.
Yeah, so Cl2 say free radical, it's used as a reagent, either so it's not. If you add this seems interesting. So concentrated H2SO4 is a dehydrating agent, which dehydration में होता है basically ये है कि you take one H and one OH and this forms H2O, and इधर जिसका जो bond आता है ये इधर कर लेता है, इधर जो उसका bond टूटता है ये इधर form कर लेता है. So you're left with CH3, CH and CH2, which is exactly what's happening here. So it would be C. And if it had been given as ethanolic or alcoholic NaOH, which can conduct elimination reactions, this would not have happened because, and I used to get confused in this, in fact. So I'll just mention it quickly. The idea is with क्या कहते हैं alcoholic NaOH for elimination reactions, उसमें क्या होता है, उसमें एक halogen होता है और एक H होता है, which get eliminated and then you form a double bond. इसमें अगर आप H2SO4 डालोगे तो this won't happen, and इसमें अगर आप alcoholic NaOH डालोगे it won't happen. They're two very different things. And propan 2-ol में आप अगर methanoic acid डालो in the hope कि आप ester बनाओ, so again it's just making an ester on the wrong side, I guess.
Yeah, because ये structure तब बनता अगर propan 2-ol की जगह propan 1-ol होता.
Exactly. So it's wrong on those grounds, and so you have 26C. So let's go to 27. Ethane 1,2-diol has the following structure. Without breaking the carbon-carbon bond, there are 5 possible oxidation groups. So मतलब इसको नहीं break करो तो there are 5 possible oxidation products. What is the total number of aldehyde groups and carboxylic acid groups in these 5 products? So इसको हम 5 products में oxidize कर सकते हैं. Okay, interesting. Like this is basically your alcohol, right? So this could ये हो सकता है कि एक alcohol oxidize और एक alcohol नहीं हो, like
हाँ यही मैं सोच रहा हूँ.
I think यही होगा, otherwise 5 ways होंगे. Like basically got alcohol because this is a primary alcohol ना, because it's the carbon that it's attached to is attached to one more carbon. So yeah. I mean if you simplify the structure बड़े अजीब तरीके से लिखा हुआ है. So basically ये ऐसे that's it. Nothing more complicated about it. So what could happen is you could either, if you have mild oxidation, it could convert into an aldehyde because इधर तो H लगा हुआ है ना. So or if you have a little strong oxidation तो ये carboxylic बन सकता है. But I think to make 5 possible, यही हो सकता है कि एक aldehyde बन जाए और दूसरा same रहे, या तो I guess दूसरा में कुछ नहीं हो, या तो दूसरा aldehyde बन जाए and इसमें कुछ नहीं हो, या ये carboxylic बन जाए और ये aldehyde ही रहे, या ये aldehyde ही रहे, या ये aldehyde रहे और ये carboxylic बन जाए. How many do you have? 1, 2, 3, 4. So you need a 5th one. ये ऐसे तो मुश्किल होगा कि एक carboxylic बन गया दूसरा कुछ भी नहीं.
हाँ ये अजीब सा सवाल है थोड़ा सा.
Yeah, exactly. I mean, I can maybe understand why one might oxidize to become an aldehyde while the other doesn't. Maybe चलो तो से reaction तो सा asymmetric हो गया. I can understand why one would be a carboxylate while the other is an aldehyde. वो reaction तो सा asymmetric हो गया. So there are 4. Oh, sorry. And then obviously the 5th one is where both of them are carboxylics. So you have 1, you have 2, you have 3, you have 4, you have 5. And the reason why we won't take the option of एक carboxylic and दूसरा कुछ भी नहीं, because इतना asymmetric oxidation तो नहीं हो सकती कि एक पूरा ही oxidize हो गया to carboxylic and दूसरा तो हुआ ही नहीं oxidize. So yeah. So what is the total number of aldehyde groups and carboxylic acid groups in these 5 products? So this is 1, 2, 3, 4, 4, and 1, 2, 3, 4. So 4. Answer is D. So 27D. Let's proceed. CH3, CH2, CO, CH2, CH3 reacts with hydrogen cyanide to form a organic particle cyanohydrin. The cyanohydric produces. Okay. So the idea here is basically this is a ketone. सही है, थोड़ी सी bad handwriting, but when you add CN to this, अगर जो this was HCN in the presence of a catalyst, अगर आप डालो NaCN या catalyst नहीं भी डालो तो कुछ ना कुछ product तो फिर भी बन जाता है. Catalyst helps, it's not necessarily needed. So what happens is, I won't draw the mechanism, but इधर के इधर जो भी bonds है वो तो सही रहते हैं, इधर आपका CN आ गया. So this happens in ketones in particular. Aldehyde में भी हो जाता है, इधर हमारे पास ketone दिया हुआ है. सही. And this is cyanohydrin. So let's look at the statements that are correct. This has 1 chiral center. Normally, yeah, but in this case, maybe not, because you look here towards the right, and the left, you have the same ethyl group. So it would not have a chiral. And उसके अलावा कोई chiral है नहीं, because सबके पास hydrogens लगे हुए. The cyanohydrin product is formed by electrophilic addition. No, this is nucleophilic addition. The cyanohydrin product formed via an intermediate which contains an OH COH group. I wouldn't say so. I think the intermediate, because what happens is, like if you draw the intermediate, सबसे पहले ये अगर ये ऑक्सीजन रहता है, इस पे नेगेटिव चार्ज आ जाता है, एंड ये CN लग जाता है. And then the second step is where your H comes in. So the intermediate is not with OH. The intermediate is this, in fact. So not this. The formation of the cyanohydride product requires the use of cyanide ions as a catalyst, with cyanide ions as CN negative. Yeah, so basically.
NaCN.
Basically, आपका ये होगा KCN और NaCN. And 28D, may you're good to go. So yeah, 28D, we're good with that. 29, compound X, where this is an secondary alcohol, CHO. So I think what basically they mean by this is either अगर आप ऐसे इधर C लगाओ, and this is an aldehyde.
Yeah.
So that's what they mean by this. And फिर उसका दूसरा C would be attached to the CH3. Is heated under reflux with excess of acidified K2Cr2O7, so basically an oxidizing agent. Both X and Y are and it forms Y, so both X and Y are separately warmed with Fehling solution and the observations noted. So idea is, the question is, two things can happen. Would this oxidize the OH to a ketone, and also would it oxidize the aldehyde to a carboxylic acid? K2Cr2O7 I think should. Excess है. The only reason I remember where it was, मतलब वो काम नहीं करता था मैग्नेट का, was breaking the double bonded.
I
think इधर तो कर लेगा. So either what would happen here is आपका either this would become a ketone, and this would become a carboxylic acid. So formed with Fehling से ketone react करेगा. So we in fact red precipitate, na? I think both X and Y should give. No,
none of them would.
Sorry.
Probably.
Like X would.
एक second. X would, Y won't.
Y won't. The reason why X would is because you can see.
Aldehyde already has.
Yeah, the aldehyde here. The reason why Y wouldn't, because the aldehyde goes to a carboxylic, this goes to ketone, so not X and Y. Only X gives a red precipitate. So we have 29B and oops. आगे बढ़ते हैं. One more question left before the big ones. So 30. Which two compounds can react together to produce an ester? So what you're looking for is a carboxylic acid and an alcohol. वैसे तो आप acyl से भी कर सकते हो, but that's not an option here. So either alcohol है, either लेकिन this is not a carboxylic acid. This is not a carboxylic acid. This is a carboxylic acid, but this is not an alcohol. This is a carboxylic acid, and this is an alcohol, so it can react. So 30C. And let's just quickly recheck, check the answers of these 10. हमने 20 से start किया था, so it's 20D, 21. Oh, we got 21 wrong. 21 is D. So 22 is A, 23 is C, 24 is B, 25 is A, 26 is C, 27 is D, 28 is D, 29 is B, 30 C. चलो, we got one wrong. 21 को हम देख लेते हैं हमने क्या किया ऐसा बेचारे के साथ. It was D, the one that we did not bother to count. Okay, let's rub this and do this again. हमने बेचारे के साथ क्या कर लिया ऐसा. Okay. So we need to figure out why it cannot be A. We can cross out B and C because structural to नहीं हो सकते. B and C तो हमने count कर लिए थे कि how they have more or less carbons. A and D had the same amount of carbons, so we have to pick one. And let's see if we can do this in a way where we don't have to count the hydrogens. That's like a lot of worry. But if you don't count the hydrogens, या तो हम इस तरीके से देखें. नहीं, but उस तरीके से भी even if you look at the branches, तो उस तरीके से भी इतना सही नहीं होगा. I think the safest way to go about is to then just count the hydrogens. So let's see on the counting में क्या मसला किया. This is 3, this is 3, 6, 1, 7, 8, 3, 8, that's 11. The 2 hoga, that's 13, 14, 14, and this is 17, 18, 19, and ये तो 22 हैं. Now let's look here. So this is 3, 2, 5, 6, 9, 11, 10, sorry, 11, 12, 15, 16, 17, 18, 19, and इधर भी 22 है. So that is, oh god, lanat, very big lanat, very big lanat. Okay, oh, besti. It's okay, happens. Look at this, yeah, it's the same structure.
Oh wait,
it's literally the same structure, yaar. हद हो गई.
Oh my god, Hassan.
So like if we call this like so like इधर ये जो इधर है वो इधर है, and if you call this A and B, this is A and this is B. I mean, instead of drawing B here, a same side with drop code, it would be easier.
Yeah.
So when I'm uploading the video, I'll just add this in the description that we got 21 wrong, but we fixed it towards the end of it, so that's fine. And that's it for this one.
Right.